Hello children, in this video we are going to study the chapter 3-dimensional geometry. But in the first video we are going to recollect the concepts which you studied already in vectors, which is the direction cosines and the direction ratios. So what is the direction cosine? Direction cosine. So you know it is cosine of the angle the line makes with the x-axis, y-axis and the z-axis. Okay. So from now onwards we represent direction cosine by the letters DC. So it is easy for us. Okay. Now look at the line OP, which is nothing but the line L. So this is the line L given to you. Now what is the angle it is making with the x-axis? It is making alpha with the x-axis. So the angle cosine of the angle it makes with the x-axis is cos alpha, and then what it makes with the y-axis? Beta. So the cosine of the angle it makes with the y-axis is cos beta, and the cosine of the angle it makes with the z-axis is gamma, which is nothing but cos gamma. So cos alpha, cos beta, cos gamma are called the direction cosines of the line OP. Suppose if the OP line, the vector OP is given by AI plus BJ plus CK. As I mentioned to you in vector class itself, ABC represents the direction. A represents from how much you travel along the x-axis. B represents how much you travel along the y-axis, and C represents how much you travel along the z-axis, which means it actually gives you the direction. Agree with me or not? So what is the direction ratio? Direction ratio is nothing but the coefficients of I, J and K. Means how far you go along x-axis, how far you go along y-axis, how far you go along z-axis. That is the direction ratio. So what is the difference between direction ratio and direction cosine? Direction ratio means just the coefficients of ij and k. Direction cosine, if you want to find, you find the unit vector along the direction of OP. So what is for finding the unit vector along OP, first we need to find the modulus, because do you remember the vector divided by its modulus is the unit vector. So OP, if you want the unit vector, it will be the vector OP divided by modulus of OP. So what is vector OP? A by square root of a square plus b square plus c square, because I am dividing it by the modulus of OP, times I plus b divided by the square root of a square plus b square plus c square, times j plus c divided by square root of a square plus b square plus c square, times k. So, when I ask you to find the direction ratio is nothing but the coefficients of ijk in a normal vector. But when I ask you to find the direction cosines, it is the coefficient of ij and k along the unit vector. Okay. So, these three are represented by the letters L, M and N. That is the conversion. And the relation between them you can find out is L square plus M square plus N square is always is equal to 1. So when you square L square, M square, N square, and if you add them, you will get 1 always. Okay. So that is a special property of direction cosines. Children, please understand one second. Please understand, if any vector is AI plus BJ plus CK, it means it is a point ABC on the coordinate axis. Okay, all means the same. Actually, it is telling you how to travel, that's all. So if I want direction ratios, it is nothing but the coefficients of ij and k. Suppose I want the direction cosines, it is nothing but the coefficients of ijk of the unit vector of that line. Okay, so suppose if I represent this as OP, because I have taken the point as P, so the direction ratio will be ABC. Okay, and the position of P will be ABC on the coordinate plane, and the direction cosines will be A by root of A square plus B square plus C square, B by root of A square plus B square plus C square, and C by root of A square plus B square plus C square. This page actually is the basic concept. So any point on the plane is ABC. The vector OP which joins O to that point will be AI plus BJ plus CK. The direction ratios is nothing but the coefficients of IJK. The direction cosine is nothing but the coefficients of IJK in the unit vector of OP. So these three things are very, very important. Please understand it carefully. And suppose if you are given 2 points in a coordinate plane, like we studied in vectors, one point is x1, y1. P is nothing but x1, y1, z1, and Q is the point x2, y2, and z2. Then the direction ratio of the line PQ. Okay, so for finding the line PQ, you know it is nothing but OQ minus OP. Agree with me? So we are going to find the direction ratio. So what is PQ? PQ is nothing but OQ minus OP. You know from vectors it is final position minus initial position. So what is OQ minus OP? OQ is x2i plus y2j plus z2k. And what is OP? x1i plus x2j plus y1j plus z1k. When you subtract them, you get x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. So once you frame the vector PQ, anybody can tell the direction ratio. What did I tell for direction ratio? When you have the vector, the coefficients of ijk represent the direction ratios, which is x2 minus x1, comma, y2 minus y1 is the coefficient of j, comma, z2 minus z1 is the coefficient of k. What you need to remember here carefully is when you find the direction ratios, you need to cancel the common because it is ratio. If there is anything in common, you should cancel. Means you cannot say the direction ratios are 2 minus 4, 6. You should tell it is 2 minus 2 and 3. Very, very important. Same way, if I ask you direction cosines, you know it is x2 minus x1 divided by, I need to find the unit vector along this. Okay, so that means I need to divide by the modulus. So what is the modulus? If I represent the modulus by the letter small r, it is nothing but x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So if I do this, if I divide by this, I will get the unit vector along PQ. So direction cosine will be x2 minus x1 by r, comma, y2 minus y1 by r, comma, z2 minus z1 divided by r. So when any 2 points are given, we find the vector along the line PQ. PQ is nothing but OQ minus OP, means final position minus initial position. You know it already. And if I do the calculations, I get this vector. So I know direction ratios are coefficients of ij and k. And when you do the direction cosine, you need to cut the common and give the answer. I told you here, remember that. Okay. And when you want the direction cosines, the first one was direction ratios. Now, if you want the direction cosines, you need to divide by the modulus of the coefficients of ij, modulus of the vector pq, which is nothing but coefficient of I square plus coefficient of j square plus coefficient of k square under root. Instead of writing so big, I mentioned it by the letter r. So, coefficient of I divided by r plus coefficient, coefficient of j divided by r, coefficient of k divided by r gives you the direction cosines. Hope it is clear for you. In our next video, we will do the problems related to direction cosine and direction ratios. Thank you.